Okay, we're gonna do this again. Real numbers. So just for reference, a real number is any number that can be written as a decimal. So that can be like, 1.000, like that can be written as a decimal. That's why it says it like that. Okay, I'm just going to go into bounded and stuff because I trust that y'all know the other stuff. So bounded intervals. Of real numbers. Let A and B be real numbers with A less than B. So I'm going to have a chart with 4 columns and 5 rows. So the first column is going to be interval notation. Next one is going to be interval type. Next one is going to be inequality notation. And the last one is going to be a graph of it, like a number line graph. So the first one is going to be the bracket A to B and closed bracket. So that type is going to be closed. For inequality notation, it's A is less than or equal to X less than or equal to B. And the graph of this is going to be the brackets there. Next one is going to be the open interval from A to B. And it is considered open. A less than X less than B. Decided I was going to go ahead and set up all my graphs so I have them. So open is going to be a parentheses at both. Next one, I have the closed interval A to the open interval B. and we call that half open. So that would be A less than or equal to X less than B. So it's going to be a bracket at A, parentheses at B. Then we've got the open interval at A to the closed interval at B. That is also considered half open. And that's going to be A less than X less than or equal to B. We've got a parentheses at A and a bracket at B. And so A and B are the endpoints of the interval. So these are considered bounded because they have a distinct endpoint. Even though it might be open, there's still an endpoint there. The next one that we're going to look at is unbounded, and what makes it unbounded is the fact that it's going to infinity because there can't be a bound there. So unbounded intervals of real numbers. So again, let A and B be real numbers. Are you all good with this chart up here? I can slide it up. Okay. So same thing. We're going to have the same categories and the same number of rows and columns. All right, so the first one is going to be closed interval from A to infinity. And this type of interval is closed. Okay, I know it's a little confusing because it has infinity, but because it has the bracket and these are unbounded, it is closed because it's closed on the one end. And the inequality notation for this is x is greater than or equal to a. So we only have a on our graph this time, and it's a bracket going towards infinity. If we had the open interval from a to infinity, that would be considered open because of that parentheses there. And this would just be that x is greater than a. So the difference in this graph is it's a parentheses going all the way. Next one, we now have negative infinity to b on the closed interval. So this one is also closed. X is less than or equal to b. So at b, we have a bracket that's opening in the negative infinity direction. And then we have negative infinity to b on the open interval. So it's going to be open, and x is less than b. And so we just have a parentheses at b this time, going toward negative infinity. So each has exactly one endpoint. So the next thing is order and interval notation. So real numbers being ordered means inequalities can be used to compare real numbers. So the book has this whole thing, and I have it written down on my paper, but we don't really end up using it because it's kind of just common sense, but that if A is greater than B, A minus B is positive. Like, a lot of it just kind of makes sense. If it would be like A is less than or equal to B, then that means A is smaller than B, so A minus B is negative, but if it's or equal to, it could also be 0. So it's kind of things that just kind of make common sense. And if you saw them, you would be like, oh yeah, like I get that. It'd be like solving the equation, basically. So I'm not going to have you write all that down because it just kind of seems unnecessary. But we do have a property here that we need to know, the trichotomy property. So let A and B be any two real numbers exactly one of the following is true. Wow, I can't spell true. That's awkward. A is less than B, A is equal to B, or A is greater than B. And then something to maybe just help you understand a little bit better. An interval is open if it does not contain the endpoints. Otherwise, it is closed. So that's why, like, the ones that, even though the infinity side is always open, we're looking at the other endpoint to see if it is open or closed. Okay. Now that I might have slightly unconfused you, are there any questions before I? Okay. So